In this lesson, you're going to learn how to multiply and divide numbers that are in scientific notation. So we have to go back to topic 3 and recall some of the properties that we used. The product of powers property tells us that when we have the same base and we're multiplying with different exponents, then we add the exponents. So b to the m times b to the n is equal to b to the m plus n power, which means if we have 10 to the 5th times 10 to the 8th, we get 10 to the 13th power when we add the exponents. And 10 to the negative 4th times 10 to the negative 5th is 10 to the negative 9th, because remember, negative 4 plus negative 5 is equal to negative 9. All right. Now the other property we used is the quotient of powers property, and that says that if you have the same base with different exponents and you're dividing them, then we have to subtract the exponents. So b to the m divided by b to the n is equal to b to the m minus n power. So if we have 10 to the 5th divided by 10 to the 3rd, we will get 10 to the 2nd power when we subtract the exponents. And 10 to the 12th divided by 10 to the 15th is 10 to the negative 3rd power, because 12 minus 15 is negative 3. Now, remember, in topic 3, we were not allowed to have negative exponents in a simplified form. But in scientific notation, we are allowed to have negative exponents. So it depends on the situation. So we are allowed to have negative exponents in scientific notation. Okay. Now, something that you have already learned many years ago is that we are allowed to multiply numbers in any order, which means, for example, if you had 3 times 2, it would equal the same thing as 2 times 3, and that is called the commutative property. So we're going to apply the commutative property, and we're going to apply the properties of exponents to multiply numbers and to divide numbers that are in scientific notation. So let's take a look at some examples. In the first example, you should notice that all we have is multiplication. We have 3.6 times 10 to the 5th times 4.8 times 10 to the 4th. So what we're going to do is we are going to use the commutative property, and we are going to multiply the first factors together, 3.6 times 4.8, and then we are going to multiply 10 to the 5th times 10 to the 4th. So that's the exact same problem, I just used the commutative property. So, we might have to do some work. We definitely have to do some work off to the side, because it is expected that you should be able to do this without a calculator. So, we need to do 3.6 times 4.8. Now, when we multiply with decimals, we do not have to line them up. So we're going to do the multiplication. 8 times 6 is 48. Carry the 4. 8 times 3 is 24. Plus 4 is 28. We have a placeholder when we multiply the 4 by 36. So 4 times 6 is 24. Carry the 2. 4 times 3 is 12. Plus 2 is 14. We add here, we get 8 12, carry the 1, 7, and 1. Now a reminder, when we multiply decimals, there are 2 numbers after decimals in the original problem, so there are 2 numbers after the decimal in the answer. So this is 17.28. Now we have 10 to the 5th times 10 to the 4th. So since we have the same base, we have to add the exponents. So we get times 10 to the 9th. And notice how I wrote the multiplication sign, because I know I'm working with scientific notation. Alright, so we have the answer, but my answer has to be in scientific notation. So we've worked on this before. We are going to review it again. The 9 as the exponent means we take this decimal point and we move it 9 places to the right. So I will use a yellow arrow to remind me I'm moving it 9 places to the right. In order for this number 17.28 to be between 1 and 10, we have to put the decimal point between the 1 and the 7 instead of where it is. So we have to move the decimal point 1 place back. So now I'm going to have 1.728. And if I put it there, that means that I have to add another decimal movement. So instead of moving it 9, that was in the yellow, I now have to move it 10. So my exponent is now a 10. And that is my answer. Let's move on to number 2. We have 5.6 times 10 to the 7th over, or divided by, 8 times 10 to the 12th. So we are going to circle this as if we have 2 different problems. We have 8.6 divided by 8, and then separately we have 10 to the 7th divided by 10 to the 12th. So let's talk about the 5.6 divided by 8. I'm going to use red here. 5.6 divided by 8. So 8 goes into 5 0 times. We have my decimal point there. And 8 goes into 56 7 times. 7 times 8 is 56. So the first number is 0.7. Now if we take a look at what I circled in yellow, we have the same base, 10. We're dividing, so that means we are going to subtract the exponents, 7 minus 12. So I'm going to do 7 minus 12, and that equals negative 5. So my exponent for the 10 is now negative 5. Alright, and then what we need to do is make sure this answer is in scientific notation. The first number has to be between 1 and 10, but it is not. So that means I have more work to do. I need this decimal point to be on the other side of the 7 so that it becomes a number between 1 and 10. This exponent here tells me I have to move my decimal point 5 times to the left. So I'm going to put an arrow and remind myself I have to move it 5 times to the left. But, like I said before, in order for this number to be between 1 and 10, my decimal point has to go here. So that means that I don't move it 5 times now, I have to move it 6 times to get to the same spot. So my first number is 7. And my exponent now becomes a 6 instead of a 5, and we're still moving it left, so it's negative 6. And that is the correct answer for number 2. Moving on to example 3, we're going to rearrange, so we're going to do 4 times 6.1 times 10 to the negative fifth times 10 to the negative eighth. We're using that commutative property. So 4 times 6.1, 4 times 1 is 4, and 4 times 6 is 24, and there is one number after a decimal point in the problem, so that means there's one number after the decimal point in the answer. So the answer is 24.4 times 10 to the, and then we add the exponents, negative 5 plus negative 8 is negative 13. So there's my answer. We check to see if it's in scientific notation. 24.4 is too big. So let's review. We know that this negative 13 as the exponent moves it left 13 times. And we need to put the decimal point right here so that the number's between 1 and 10. So it's 2.44 times 10 to a power. Before I had to move it 13 times to the left, but I already move it 1 time to the left, so that means I now only have to move it 12 times to the left to be in the same spot. So that is my answer, 2.44 times 10 to the negative 12. All right, and then the last example, example 4, we have 2.55 divided by 5, and we have 10 to the 6th divided by 10 to the negative third. So let's do the division first. 2.55 divided by 5. 5 goes into 2 0 times. Put your decimal point there. Then ask how many times does 5 go into 25. It goes in 5 times. That's 25. Subtract and you get 0. Drop down the 5. 5 goes into 5 once, which is 5. And we get 0 as the remainder. So this red part is 0.51. In the yellow, we have to subtract the exponents, and some of us really have a hard time with subtracting negatives. Remember, it's 6 minus negative 3. And you learned last year when we have subtracting a negative, you guys said keep, add, opposite. So you keep the first term, you add instead of subtract, and you take the opposite of negative 3. So keep, add, opposite. So this ends up to be 6 plus 3. So that means that the exponent is 9. So it's 0.51 times 10 to the 9th. Is that in scientific notation? It needs to be. This number here has to be between 1 and 10, and it's not. We need to move that decimal point one place over. So the exponent of 9 here tells me that I need to move the decimal point 9 times to the right. But in scientific notation, we need the decimal point to be between this 5 and 1, 5.1. So since I already moved it 1 time, I only have to move it 8 more times to be in the same spot. So it's times 10 to the 8th. And that is the answer. So with those examples, you should be able to multiply and divide numbers that are in scientific notation.